Hello everybody and welcome back to our Let's Make Games series. Last time we had just started the player entity and we now have the ability to apply acceleration to the player and move the ship around the screen using some basic two-dimensional acceleration physics. Now let's get started making the asteroid entity. So inside our asteroids project we're going to add a new class. We're going to call this Asteroid. This will be public, and we're going to inherit from entity. Make the constructor. Also need the model game namespace, so let's bring that in. Alright, in the base class, when we create a new asteroid, I want it to actually create something random. So we're going to have random vertices, we're going to have a random position, and probably a random velocity as well. For the vertices, when we pass the vertices into the base class, or the parent class, I'm going to pass in null because we're actually going to use the asteroid constructor itself to construct a random asteroid. The position is just going to be a 0 vector. As far as the parent class is concerned, we're just passing a vector 0, and inside the asteroid constructor itself we'll make a random position for that. And the color, we'll just, for now, let's just make everything a brown color. I want to pass in a random number generator object into the constructor, so then every asteroid we create will use the same random number generator. And that way we can have consistency in the random numbers that are generated. The first thing I want to do is generate the vertices of the asteroid. And let's go ahead and draw something here. So this will be our center point. We're just going to go around in a circle and just start generating random points at random distances. Okay, so we'll have the first distance will come out and we'll put a point here, and then maybe the next distance looks like this, and so it'll be a point here, and then maybe the next distance will come out longer and be here. Okay, so we're going to have a random distance. So we'll just have a random number of points that we're going to go around and just start generating some random points out there that are random distances from the center point of the asteroid. Let's go ahead and pick a random number for the number of points on the asteroid. I'm going to use the random number generator to get a random number between two values. And let's see, there is an overloaded, yeah, we can put a minimum and a maximum in here for what range we want to get an integer. So let's make some variables up here. So the min points is going to be, let's just pick a minimum number of points of 6, and the max points will be something like 10. Let's just see, again, we're just seeing how this looks. We can change this obviously later. So put the min points there and the max points here. So now we know how many points are going to be in there. We can actually create the vertex array. So this will be a new array of vector 2 structures, and we're going to put points in there for the number. Now let's go ahead and loop through all the points and create our asteroid. First of all, we need to know the delta angle, and that's how far we're going to advance the angle every time we go around to the next point. 2 pi would get us all the way around, but we need to divide that by the number of points we have. So we're going to do 2 pi divided by points, and we'll just cast this into a floating point value. And then we're going to have the actual angle where we are currently doing our operation. Alright, so now we have the number of points to go all the way around, and now we just need to pick random distances. And that'll be inside the loop. Let's pick some random distances. Actually, outside the loop, let's make a minimum and a maximum. So the min distance will be 12, and remember we're talking about meters, and the max distance will be, I don't know, 24. I guess we'll just double it and see what that looks like. Now the actual distance we will figure out here, and we want to pick a random number that's between 12 and 24. I'm actually going to go back into our flat library. I'm going to create a new class that's going to help us with this, because this is something I want to be able to do on a regular basis, and I'm going to call this a random helper class, and it's going to be a static class that will just help me pick random numbers. Okay, and the first one I want to make will give us a random single between a minimum and a maximum. Let's go ahead and pass in the random number generator object that we're using. We want to start at the minimum, and then we're going to pick a random number, a random single, so we'll get a next double, and let's cast this into a floating point single value. And then we're going to multiply that, because so now the next double is going to give us a value between 0 and 1. So then that's kind of a normalized floating point value that we can then multiply by the difference between the maximum and the minimum. So the difference between the maximum and the minimum in this case is going to be between 12 and 24. So max minus min is going to return 12. And then if we multiply by this value, this random value that's between 0 and 1, it'll then give us a random value between 0 and 12. And then we just add it back into the minimum to get back to our range of values. And I also want to do just a quick check. Let's make sure that the min is less than the max. So if the minimum is greater than the maximum, let's just throw a new argument out of range exception. Okay, that looks good. So let's go back to our asteroid creation class. So now we're going to bring in the random helper. Oh, and actually we need the namespace for the flat library, so we'll use flat there. Random helper, we want to get a random single between the min distance and the max distance. Let's go ahead and get the x and the y. The x is, we can get the x component by just taking the cosine of the current angle, and then we'll get the sine of the angle will give us the y component. And then we just multiply this by our random distance. And so now we have everything we need to add this vertex to the list. So at this vertex index, we're going to create a new vector 2 that'll be x and y. So that'll create all the vertices there. Let's go ahead and make a random position on the screen, and in order to do that I want to pass in the camera class so we can get the extents of what we can actually see. And we don't have access to that yet, so let's bring in the namespace for that. That'll be under the graphics for the flat library. Let's get the extents of the camera. Let's get that as a vector 2. We're going to do the camera min and the camera max. Alright, now that we have that, let's pick a random value between this minimum and this maximum. So the position x is going to be let's use the random helper. We'll get a single between the camera, we're going to use the camera min x and the camera max x. Let's do the same thing for the y, and we'll just change these to the y values. That'll give us a position that's all the way from either the far left or the far right, but I'd rather have the asteroids just a little bit closer in instead of extending all the way to the edge at the very beginning. Let's divide the minimum vectors by, let's see, if we divide by 2, and you know what, actually let's just multiply this. So if we multiply by 0.5, that'll make the maximum range about halfway out. But I want to go a little bit further than that, so let's multiply by 0.75, and that'll give us 3/4 of the view on either side from the center. And then we'll just do the same thing for the maximum. The position of this asteroid is going to be equal to a new vector that's going to be the px or the py. Okay, so we have a random we have the random vertices, we have the random position, and let's create a random velocity. Actually, inside a random helper, let's make one more function that's going to just pick a random direction. So the velocity is going to have a magnitude, meaning this is my speed, but I also need to have a direction component to it. So let's make something that will give us a random direction. You need the monogame namespace in here. So the first thing we're going to do is pick a random angle in radians, and so we can just pick a random single using our random helper class. So the random single is going to be between 0 and keep forgetting to do this, but we need to pass in the random number generator. Okay, so a random single, and we want to start at 0 radians, and the maximum will be 2 pi radians. So that'll just pick a random angle that could be anything from 0 to all the way to 2 pi radians. Okay, now that we have a random angle, let's convert that to a direction. And we've done that before. The new vector 2, and then the x component is simply the cosine of that angle, and the y component is the sine of that angle. That's going to give us a random direction. So let's make a velocity direction. And we'll use the random helper to get a random direction. We need to pass in the random objects. All right, next we need a velocity magnitude. And let's just abbreviate these. All right, the velocity magnitude is going to be a random single between some minimum and maximums. This is the speed. And actually, I'm going to call it speed instead of velocity magnitude. There, that'll be the speed. So let's make a min speed. What do I want that to be like? Let's just go ahead and throw a number in here like 20, and the max speed will be twice that, so 40. The min speed and the max speed. There we go. And then from there, I can just multiply the velocity direction times the speed, and that'll give us a random velocity. Okay, so we have created our random asteroid now. The base class entity should now update according to these parameters, the position with the velocity, and then we should be able to draw it just fine here with that. So back in our game class, we now want to make a collection of entities. I'm going to make this a list, a generic list that's going to be entity, and I'm just going to call this entities for now. We are actually going to get rid of this main ship player object, and I'm just going to include that in the entity list. And the first entity in the list is always going to be the player. So if we ever want to look up the player, we just reference the first entity in the entity list. Down here, we don't have the player anymore, so the player will actually be initialized locally here, and then we're going to save it to the list. So this will be a main ship. Up here, let's go ahead and create the list of entities. All right, so there's the entity list. It'll just be a new list. And the first thing we're going to do is add the player to the entity list. Now we need to add all the asteroids to the list as well. So let's go ahead and make an asteroid count. I'm going to make the asteroid count to start off as 5. So we'll have 5 asteroids. Let's loop through the asteroid count. We will create a new asteroid. We need to, with a random number generator, and we'll pass in the camera. And in the entity list, we're going to add the asteroid to the list. So that should create 5 randomly generated asteroids. The only thing missing now is we need our random number generator. So up at the top here, let's see, right before we create our entities, let's make a random number generator. I want it to have the same random seed every time so we get the same results every time. So I'm just going to pass in 0 for that. So that should generate 5 asteroids. We've created our player, added the player to the first position of our entity list. Then we added 5 asteroids to the list. Now all we have to do is, okay, we don't have a player as a game object anymore. This is part of the entity list. So let's go ahead and get the player. So the main ship player is going to be the first object in the entity list. And we need to cast that into a main ship. Then we can just remove this. Now, as far as the player update, we're not actually going to do that anymore. We're going to update all of the entities all at once. So we're going to loop through each entity. So here's all of the entities count. And then for every entity, we're just going to call the update function and pass in the game time and the camera. Okay, so that'll take care of updating. And then we just need to do the same thing for drawing these entities. So we'll just copy this. Come down to the draw command. We're not actually going to do the player by itself. We're going to do all of the entities together right here. Okay, and instead of calling update, we're going to call draw. Okay, and so that should draw everything. Oh, and the function, what does it need here? It wants the shape batcher, so let's pass that in. Okay, that looks good, and let's run that and just see what we get. And that did not work. Although I see some lines on the screen, and it looks like we have random directions. For some reason, it's just showing up as one single. Oh, okay. So it's showing up as a single line. Everything looks like it's working well, and they're actually, I can see that they're updating correctly. Everything looks like it works except for they're not drawing correctly. And what happened inside our asteroid class is we did all of this correctly, but we failed to advance to the next angle every time that we wanted to create the next point. Now we need to move the angle by to the next point. All right. So now it should be advancing the local angle. Yeah, and it says local angle right there, and we should be getting different results now. All right, so that's taken care of. Let's run that. There we go. Okay, so there's our asteroids. They're all kind of moving along at their own velocity. It looks like totally random directions. That looks great. I like the shape of these asteroids. I like the way they turned out. We can do some tweaking to that later. Obviously, they're not colliding with each other yet, but that'll be something for a future video. That is our win for the day. That looks really good. It's really neat when you can start seeing it coming together. I mean, it just feels really neat to see it. You see the pieces kind of falling together, and I'm really enjoying the way this looks. That's turning out really good.